I just want to check. Can everybody see my my camera slash stream?
Yeah, but it's upside down. It looks like the upside down.
It's flipped.
Oh, it's
Yeah,
flipped.
it's flipped.
Okay, okay, okay. Hold on, hold on. I can fix this. I can fix this. How about now?
Oh,
Yep,
that's
works.
perfect.
Okay. All right. So you guys can see it, read it the right way.
Yep.
Okay. See, for me now it looks backwards. Okay. All right. So as long as it works for you guys, that's all that matters. Welcome. We're finally gonna finish up this series. This is week 9 out of 10, and this week we're gonna talk about radar services and navigation, and some of the ways that we can navigate around tricky areas of the world. So we'll get right into it. So we're going to talk about navigation systems and radar services. So we're going to talk about some of the navigation aids. So there's things like VORs, VORTACs, DMEs, satellite-based navigation. We're going to talk about the global positioning system, and then we'll talk about radar service and the procedures associated. So we'll get right into it. And guys, if you have any questions or confused about anything, don't be afraid to stop me. Just let me finish what I'm saying, and then you can interrupt. So first things first, we're going to talk about VORs. And so a VOR stands for a very high frequency omnidirectional range. So this is a ground-based radio station. And there's 3 types. There's a VOR, right, which is just a plain old station. There's a VOR DME, which is a combination of a VOR and a distance measuring equipment. And then there's a VORTAC, which is a combination of a VOR and this thing called a TACAN, which we'll talk about in a little bit. This is the most common radio navigation system, right? You will find these all over the U.S., and they're typically the primary source of navigation when you're not using GPS or internal navigation. So these project radio signals between 108 and 117.995 megahertz, and they transmit radials, or essentially you can think of like imaginary lines that are 1 degree each in width, and there's 360 of them. So you get a 360-degree circle of these radials. And so the accuracy of these VORs is plus or minus 1 degree. So there's a little bit of some downsides with these VORs. So they're subject to line of sight restriction. So what we mean by that, if you have a VOR station, you know, on one part of the Earth, and you have a VOR station on the other side of the Earth, not that they go this far, but this is just a hypothetical to show you. If you're in the range or line of sight of this VOR, you might not be in the line of sight of this VOR on the right. And then there's obviously a point where you can get both signals. And then there's also a point, again, where you can get neither signal. So each VOR station, we need to identify that to make sure that we're using the right VOR, as they are a radio-based navigation aid. And we need to make sure that it's eligible and active and it's not under maintenance, so it's reliable. So first, we want to tune to it, right? We take our nav radio and we apply the VOR frequency. And then I don't know if you can do this in most SIMs, but what you want to do, if you can, is listen to that nav frequency and identify the Morse code that the VOR will broadcast. You can actually tune into a nav frequency and listen to it and make sure that it matches the chart. And what I mean by that is, if you look at this example down here in the bottom right, this is the Deer Park VOR DME, and it says it's 117.7. That's our frequency. It gives us the 3-letter identifier, but it also gives us the coded identification. So it's got a long, a short, a short, long, long, short, and a long, short, long. So we would hear that depicted with a bunch of beeps in that order when we would tune into the nav frequency. Any questions so far? All right, cool. And one other thing I'd like to mention is that, like I mentioned, if the VOR is under maintenance or it's not reliable, it may not transmit a code, and in that case you have to assume the VOR is not out of service, or it might transmit a test code, which is literally test in Morse code. So we talked about line of sight. Now let's talk about the 3 types of like service volumes for VORs. This is what we call essentially the range for which the VORs are certified for. So there's a high altitude VOR, there's a low altitude VOR, and then there's a terminal VOR. The lowest distance and least powerful VOR is referred to as a terminal VOR. It stretches from 1,000. It will guarantee reception from 1,000 feet AGL to 12,000 feet AGL within a 25 nautical mile radius. A low altitude VOR is getting slightly more powerful. It'll go from 1,000 feet AGL to 18,000 feet AGL and has a 40 nautical mile radius. And finally, the most powerful VOR in terms of range is the high altitude VOR, and it's a little bit complicated. So it goes from 1,000 feet to 14,500 feet. You get a range of 40 nautical miles. From 14,500 to 18,000 feet, you get a range. I'm sorry. Yes, okay, 14,500 to 18,000, you get a range of 100 nautical miles. From 18,000 to 45,000, you get a range of 130 nautical miles. And then on the top end, from 45,000 to 60,000, it shrinks back to 100 nautical miles. So it kind of stacked like a weird kind of cake, if you could think of it that way. And depending on where you are in relation to this cake is whether or not you're going to get reception from the VOR. So we talked about VORTAC earlier. So a VOR or a VORTAC is a combination of a VOR and a TACAN. And you might be thinking, well, what's a TACAN? Well, a TACAN is a navigation system used by the military. I don't know if we have any DCS players in here, but it stands for Tactical Air Navigation. And it's just a more reliable and precise navigation aid. Now, this includes a distance measuring equipment by default, and we'll talk about what that is in a little bit. So you might be asking, well, why do these VORTACs exist? So the military came out and said, well, civil VOR and DME is not suitable for military or naval use. It's more accurate, it's portable, right? So they can throw these things on aircraft carriers or destroyers, and they can have aircraft navigate themselves with their TACAN receivers. And then, of course, there's VOR DME. So this is a combination of a VOR and distance measuring equipment. And this allows you to receive slant range distance from the VOR. So what is slant range distance? So instead of telling you what the distance would be over the ground, it's literally it's going to broadcast a signal from you directly to the station, and it's going to tell you what that distance is. So if you're at altitude, obviously you're not on the ground, and there's some trigonometry involved. You're not going to be the same distance over the ground as you would be slant range. That DME operates on frequencies from 960 megahertz to 1,215 megahertz. And there's no need to tune that frequency. It's automatically tuned and dialed in when you tune to the VOR DME. So that line of sight is reliable within 199 nautical miles. Any questions so far?
No, that's good.
All right, cool. So we're going to talk a little bit about how we would use the VOR. And there's going to be a live demo here in a minute. So first things first, you're going to pull up a sectional chart or a terminal area chart, and you're going to find the proper frequency of the VOR you want to use. You want to input that frequency into either the NAV1 or NAV2 if equipped in that radio panel. You're going to listen to the NAV frequency to make sure the Morse code matches. Again, make sure you hear the code that's on the chart like we showed before. And you want to look at the VOR indicator and verify that there's no red flag. If there's a red flag, obviously the VOR is not suitable for use. And then you want to turn your OBS or your Omni bearing selector to the desired radial or course index. So we'll go ahead and show you this this live demo. So this is a kind of simulator of how a VOR works. And so there's one thing I want you guys to remember. Your heading does not matter at all in relation to a VOR. If you're using just a plain old CDI like this, your heading is irrelevant. It's not going to be displayed anywhere. So you see in this simulation here, here's the airplane, and I have tuned in that I want to be on the 221 radial. So here, if you look here at the OBS, I have a 221 radial set. And if you look here at the map, it says, okay, you have a 221 radial set. So what that means is any time that I'm directly on this radial, the white line on the CDI, the course deviation indicator, is going to be directly centered. Now, if I move to the left, what's going to happen is it's going to move, right? It's either going to move left or right, depending on which way I am. So this is where it can get a little bit tricky. So if you notice, there's also this 2 and FR, and there's an arrow pointing at it. So this is telling you which side of the VOR you're on. So you see how there's this white line here that separates the to and the from. So you have to think sort of as if which line you're saying. So this is saying that you're on the 221 radial, and the radial is coming from the VOR. Now here's the thing. I can leave that, but if I were to be on the other side of the VOR, I'm still on the 221 radial, but it's taking me to the VOR. So the radial's on the opposite side of the VOR. In other words, what this means is that if you have a 2 flag and a radial set, we have 221 here, if you're at that line is centered and you fly a 221 heading, that's going to take you to the VOR. Now, this can go for anything, right? So, for example, if I rotate the plane here, right, like I said, nothing's happening as I change the heading. If I look at the line here, I get a 2 flag to the VOR. That means that I can basically fly whatever direction this line is. Only when I have a 2 indication, I can fly whatever direction this line is. So 221, if I were to fly anything from 221 all the way around to its reciprocal, which is, let me do some quick math here, all the way to 041. If I were to, fly in that general direction, so westbound, I would intercept that radial. And you see that as I intercept it, the CDI is starting to move towards the center. If I'm on the eastern side, or I'm sorry, if I'm on the west side and I want to fly now eastbound, I can now re-intercept that radial. Now here's again where it gets tricky. Let's say I'm on the other side of the VOR. Well, if I'm on the west side, right? If I fly towards the VOR, right? If I fly towards the needle in the airplane, I'm actually going to be moving further and further away, right? So this needle's to the left, right? If I now continue left, see how the needle moves to the right? This is called reverse sensing. So the way we can eliminate this is if we just flip it 180 degrees. So if I go, now it's accurate again, because now it's coming away from the VOR. So yeah, that's just one way that we can use VORs to our advantage. So let's move on. Does anybody have questions about that? I actually think I may have demonstrated that wrong here. Let's just double check. Okay, yes. So if it's coming from the VOR and you are on the from side of the VOR, you can use it reliably. Otherwise, you have to swap the side. Does that make sense to everybody? Any questions?
So that basically means that when you're flying away from the VOR and the 2 flag is shown, you've got the reverse sensing.
Exactly. So if you're flying away from the VOR but have a 2 flag, you're going to get reverse sensing. If you're flying to the VOR and you have a 2 flag, you're going to get normal sensing. So when you're flying away from the VOR, you want to have a from flag showing.
Okay. Thanks.
And then you can use that to navigate away from the VOR. So here, I'll set that back to... So here we go. We would be from the VOR. If I get to the left, okay, I know I need to fly to the right to get back onto the radial. If I'm to the right, I know I need to fly a little bit to the left to get back on the radial. All right. I think that is a good explanation. So,
I've got a question from earlier.
Yeah, sure.
When you were talking about the distances and the altitudes for the VORs, below like 1,000 feet, there was like a semi-sphere. Is that an unreliable area?
Yep. So what that's considered, obviously when you're close enough to the VOR, you start to get what this thing is called. It's called the cone of confusion, and it's essentially just an area where the VOR is not accurate because you're mixing all the radials together at that point. So when you're below 1,000 feet AGL, there might be some obstructions that are close to the VOR that prevent it from being reliable. Physical obstructions like trees or other words, because the VOR is broadcasting upwards. So if you're low below 1,000 AGL, you're not going to be able to get a reliable signal. Okay, so Section 2, satellite-based navigation. So space-based radio navigation is used all over the place, right? We use that in our cell phones, in the cars. Tesla makes a big deal of it, right? They're using that to get your car to drive itself from point A to B. It's very, very, very important. So it's typically made up of, well, it is made up of satellites, but in our cases, it's typically using the United States GPS network. So there's a 24 satellite constellation. I actually believe it's more than that now. The U.S. has been adding more and more GPS Block 3 satellites. And it's designed to ensure at least 5 satellites are visible to a user, aka an aircraft. And the Department of Defense is responsible for operating GPS satellites. There's other GPS constellations like GLONASS, that's the Russian version. There's Galileo, which is the European version. And then there's also Baidu, which is the Chinese version, which is currently in development. If this doesn't want to change. So there's 3 functional elements. There's the space element, the control element, and the user element. The space element consists of 24 Navstar satellites. That was the base. I believe there's a little bit more now. They're set up at 6 different orbits, and they're 11,000 miles above the Earth. The controls portion is GPS monitoring stations on the ground, right? And that's also being controlled by the U.S. military, right? It keeps all the clocks consistent, and it keeps everything in time. And then there's the user portion, which is the antenna and the receiver on the aircraft. So that's your GPS unit, right? Your Garmin 430, your 650, whatever unit you may use. So GPS receivers are able to receive the radio signals from those satellites. And the why this is important. Satellites will send radio signals to the receiver at a specified speed. The receivers use the radio signal to calculate how long it took to get to the receiver. If you know the speed of it, the distance from the satellite can be calculated, right? So when you have several satellites that are in sight and they're all performing that calculation, you can triangulate your position based on the distance from each satellite. So that allows you to get at least your location, but in some cases also your altitude, and that's where you get into the ability to do things like GPS approaches for P2. But for basic VFR navigation for P1, it allows you to get your position. One thing to remember is only GPS units mounted in the plane are approved for navigation. So, and that's because the antennas are placed in clear view of satellites, and they have Raim capabilities. Now, we'll talk about Raim here in a second. So, Raim, you might think, well, that's a weird acronym. And it is. It stands for Receiver Autonomous Integrity Monitoring. And this is essentially just a verification that there is a sufficient amount of satellites in order to provide a correct position. So this is typically used in IFR navigation. It's not so important in VFR navigation, as again, the GPS is there as a sort of situational awareness tool. It can be used, of course, to get from point A to B, but it's not required to be 100% accurate. So Raim says this: with 3 satellites, Raim can guarantee a 2D position, so a lat and longitude. With 4 satellites, you can get a 3D position, so that's latitude, longitude, and altitude. With 5 satellites, you can get 3D position with Raim. So that's essentially taking the the longitude, latitude, and altitude, and you're error checking it to make sure it's correct, because that data might not always be accurate. But if you cross-check the data with 5 different satellites, you can verify that it's accurate. So it can be used as an aid to situational awareness, the GPS, as well as for navigation. But of course, if you have something like a handheld GPS, it can be used, but only for situational awareness. But they don't have Raim capability, hence you're not able to use them for navigational reasons. It's important that we keep the databases of these current. More important for IFR, as it's required by law that waypoints for approaches and the database is current. But again, it's important that just for safety, obviously in the sim, not a huge deal, that these databases and the data the GPS has is up to date. So let's talk about radar services a little bit. Radar services are provided by air traffic control. They're used primarily for aircraft separation, and VFR aircraft, right? So what we're doing for P1 are going to receive assistance workload permitting. On VATSIM, most of the time that means you're going to get service. So what do we get by talking to air traffic controllers? Well, we get some assistance. If we're in complex airspace, we get vectors through airspace or a corridor, right? If we're in a Class Bravo airspace, we have to be cleared into the Bravo. We make it flight following. So on long cross countries, if we want to call air traffic control, and obviously we can't file an IFR flight plan, this is just a way to get traffic advisories while we're going on and doing our own thing navigating. And then also, in the event that you become lost, you can get some navigational assistance, right? If you get lost, there's those 5 C's. You want to climb, conserve, confess, communicate, and circle. And then, obviously, call for help, right? That's the confess portion. And ATC is there to help you if you do get lost. Yeah. So that's all we have today on radar services and ground-based navigation and radio navigation. If you don't have any questions, I will hopefully see you next week. But if we have any questions, we can go ahead and do that.
Looks like nobody has questions.
Yeah. Okay. All right. I guess we
Well,
covered.
if nobody else has questions, I've got like 4, I think.
Yeah. Sure.
Maybe a more technical one first. Is the DME or like what? How does the DME work? Just basic. Is it round trip time based?
So it's the same way as how that GPS works. It knows the speed of the signal, and it's measuring the time of how long it takes to send the signal back and forth.
Okay. Yeah. And speaking of the VORs, is the different distances for the VOR, the high altitude VOR, are those caused by the physics of it, or
it's the design? It's designed to give that kind of range, and you typically won't see that many high VORs. You'll find them more like across the country for like long jetway routes, which are VOR based high altitude routes. So we don't really have to worry about those too much. You're going to be more focused with the low altitude and the terminal. But the reason it's important to know is because if you're on a cross country and you're at a certain altitude, if you're at 5,000 feet and you're not picking up a VOR, well, the reason might be it's a high VOR and you're not within the service volume. That's why it's important that we know what the service volumes are.
Okay. And this is a question regarding another class, like the first one, which I watched yesterday. I like the recording from YouTube. If that's okay.
Yeah, sure.
Regarding the lift of airfoils, in the video somebody else asked a question. If I think it was like if you flip the wing upside down and fly inverted, the airfoil would produce lift gravity, I think you said in the video. But if I got it correctly, the lift is always in the direction of the angle of attack. So if you angle the airfoil upwards, and then the low pressure side, the high pressure side would build on the bottom of the wing, so it would produce lift upwards.
It depends on whatever way the airfoil is deflecting the air, because the angle of attack could be facing one way. So that's where you get into Newton's third law. If it's deflecting air down, you're going to get a force in the opposite direction. So that's why if you're inverted, right, you're going to be partially, obviously, the nose of the airplane is going to be pointed towards the sky still. So the airfoil is still going to be deflecting air towards the surface, hence the airplane's going to stay flying.
And even though it's a stupid idea, flying inverted with cambered wings is probably a bad idea because it's less efficient, right?
It's less efficient, right? That's where that Newton's third law comes in. It's designed, obviously, to be efficient at normal flight, but if you're going to fly inverted, it will because of Newton's third law.
Okay. And the last question, I just by sheer luck catch the series on the Discord. Will it be repeated, like the live sessions, or how does that work?
What do you mean? Like
I watched the recording of like the first lesson yesterday on YouTube, and I just catch this I don't know, it's week 10 or something.
Oh,
now.
so yeah, the last week is next week. That's going to be the conclusion of the ground school.
And will that be repeated afterwards?
Oh,
or...
yeah, no. So that's why we have the recordings.
Okay.
This is
so
just
the-
like
the
it was like a
recordings of the
one-time.
series.
Yeah, exactly.
Yeah. Okay.
All right.
I do have a question.
Sure.
The VOR signals, it could be affected by the clouds and thunderstorms.
Clouds, no. Thunderstorms, I would assume no also, but now you've got me asking myself questions because, obviously there's static electricity involved. But for the most part, the answer is no.
Okay. And last question, it was, I noticed the NDB was not mentioned.
Yeah, so in the U.S., NDBs are practically decommissioned everywhere. They're sort of not even taught anymore, right? If you're going for an instrument rating in the U.S., they're just not even taught. So we're not going to go over them because it's kind of outside the scope of my knowledge because I never learned them either in the real world. And in the U.S., you're never really going to even use them. So there are some resources online. If you go to Europe and the rest of the world, NDBs obviously are still in active use.
We have plenty here in Canada.
Yeah, but for our purposes, right? But we're U.S. based. We didn't feel it was necessary to dive into it.
Okay. Okay, thank you.
Actually, I had a follow-up question on that.
Yep.
So how long before VORs aren't even taught anymore? Are they on their way out as well?
No. Okay. So this is a very, a lot of people are misinformed about this. So VORs are being reduced, right? People think, oh, VORs are all getting retired. That is not true at all. If you go to the FAA's website, and I can only speak for the FAA. The FAA has guaranteed a VOR MON, a minimum operational network, which consists of I think 100 or maybe 200 and something VORs around the country that are going to remain in service and be refurbished and stay up to date for the foreseeable future. I don't know what the exact number is, but VORs are, as far as this point, not on their way out because we do need a backup in the event of a GPS failure. Obviously, GPS is susceptible to a lot of failures, right? If we were in wartime, we might shut down GPS right to civilian use. And in that case, we would need a backup. So I think I don't know what the exact number of the minimum operational network is. But it is a sufficient amount to maintain navigation in the event of an entire GPS failure. Oh, okay. So it's 500 VORs are going to remain in service.
That's a lot.
Yep.
All right, so the old school navigation methods are still a thing. Nice, thank you.
Yeah, for VORs at least. All right. Anybody else?
Yeah, I've got a couple for you.
Sure.
So you said that the VOR DMEs would communicate the distance, like from your plane to the VOR, right? But how is that communicated to the pilot? Like, is that just with the to and from arrow, or?
Okay, so I should have clarified this just a little bit more. It is reliant that the airplane is DME equipped. So a DME is another receiver in the airplane. The airplane does need to be equipped with that.
Perfect. Okay, thanks.
So in the event that you don't have that, you would just use your GPS or whatever if you had one. Otherwise, you don't have you're non-DME equipped.
Right. I was also wondering. Someone asked, like they said that this was week 9 out of 10.
Yep.
So after week 10, what's the next step? What do you do next?
In terms of what?
Like for the PPL.
For P1?
Yeah.
You can continue online with the training online on the VATSTAR website. If you go to VATSTAR's website and proceed to the training section on your profile, there's a whole section of lessons and whatnot that you can go look through and briefly read through. And then when you feel ready and comfortable, you can go take the P1 written test. And at that point, you're eligible for practice flights and the check ride for P1.
So this is where people get confused. The ground school is not the training. It's just a supplementary tool to help you understand the the coursework. What you have to do is go through the actual reading and then take your practice exam, your written exam, and then your practice license and your certified through the website. This ground school is just an extra little course on the side.
I didn't even know you showed up, Edward.
Oh, I'm sneaky like you
Yeah.
are on my Discovery flights.
I know. But yeah, that's all I have for you guys. Any other finishing up questions?
Are there any plans to do something similar for like the P2 instrument rating with these videos?
You're gonna have to ask me in about 2 months.
Okay, sounds good. Thank you.
Of course. All right. Well, it was good seeing you guys show up for this, and hopefully we're on schedule for next week. I'll have a nice presentation set up, and that'll wrap up the P1 ground school. So thanks guys for coming. It was good being with you.
Thank
Thanks,
you.
man.
Thank you.
very much. Appreciate your time.
I really appreciate your explanation.
Thank you.